Ever get that feeling, when you look up at the night sky? Like something's calling you out there. Beyond those constellations we know so well.
Yeah.
Well, that's the Milky Way calling. That's our galactic home.
Yeah.
Billions of stars, trillions of planets swirling gas clouds. It's amazing, a whole universe just crammed into a single spiral.
I know, right?
And today, we're strapping in for a journey across this cosmic expanse.
Buckle up.
Welcome to Cosmos, in a Pod Space and Astronomy series.
It's so cool, right? Because we're not just looking at static points of light.
Right.
It's a living galaxy, breathing with stories, constantly unfolding births, deaths, collisions.
Wow.
It's drama on a scale that makes Earth's history look like a blink.
So let's unpack that drama, shall we?
Let's do it.
Starting close to home, Alpha Centauri.
Yeah.
That's the system everyone's buzzing about these days, right?
Right. Our closest stellar neighbor, just over 4 light years away.
Wow.
And it's not just one star, but 3 dancing around each other. Alpha Centauri A and B, both pretty similar to our sun. And then there's Proxima Centauri, a much smaller, cooler red dwarf.
Proxima Centauri. Now, didn't they find a planet there that might be habitable?
They did. It's called Proxima Centauri B, and it orbits in the habitable zone.
Okay.
Meaning it's the right distance from its star for liquid water to possibly exist.
That's so cool.
But here's the thing. Red dwarf stars, they're kind of notorious for powerful flares, these bursts of radiation that could sterilize any planets close by.
Oh.
So whether life could actually survive there is a big question mark.
Okay, so maybe not the best place to look for a vacation home.
Maybe not.
What about Barnard's Star? I remember that name for Center.
Another red dwarf. This one's a speed demon, though.
Really?
Yeah, moving across the sky faster than any other star we see.
Wow.
And it has a planet, too, Barnard's Star B. It's what we call a super-Earth.
Super-Earth.
Yeah, meaning it's bigger than our planet, but smaller than a gas giant.
Okay, is this one habitable?
It's possible, but in a way we don't usually imagine. The planet's surface is probably incredibly cold, around -168 degrees Celsius.
Yeah.
But some scientists think there could be a subsurface ocean, warmed by the planet's internal heat. It's a good reminder that life might exist in places we wouldn't expect, even in our own backyard.
Subsurface oceans. I mean, that's where things get really interesting.
Yeah.
What kind of life could evolve in a place like that?
Yeah, I know. It's wild to think about. We can only speculate, really.
Yeah.
But it opens up this whole new realm of possibilities.
Yeah.
Imagine creatures adapted to eternal darkness, thriving on geothermal energy instead of sunlight.
Wow.
It really challenges our very definition of habitable.
It really does. Speaking of backyard wonders, what about Sirius?
Oh, yeah.
That's the brightest star in our sky, isn't it?
It is. It's another binary system, but much different from Alpha Centauri.
How so?
Well, Sirius A is a massive blue-white star about twice the size of our sun.
Wow.
And its companion, Sirius B, is a white dwarf, the dense collapsed core of a star that's already gone through its life cycle.
Oh, wow. So it's like a cosmic graveyard orbiting a blazing inferno.
Kind of, yeah.
I'm guessing no planets there.
None that we've found yet. But that doesn't mean they're not there. We're always refining our methods of detection.
Right.
Who knows what surprises are lurking around even the most familiar stars.
So we've done a quick tour of our neighborhood.
Yeah.
Now let's venture a bit further out, shall we?
Let's go.
What are some of the more exotic exoplanets we've discovered?
Oh, we're talking about planets that push the boundaries of what we thought was possible.
Like?
Take Wolf 1061c, for example.
Okay.
It's a super-Earth orbiting a red dwarf star, and it's really caught our attention because it sits right in the habitable zone.
Oh, so another potential water world.
Possibly. But here's what's really interesting. Red dwarfs have much smaller habitable zones than our sun.
Oh.
That means planets like Wolf 1061c are tidally locked.
Tidally locked.
One side always faces the star, the other always faces away.
Oh, wow. So you'd have like a permanent day side and a permanent night side.
Exactly. Imagine the extreme scorching heat on one side, eternal darkness on the other.
That's wild.
Makes you wonder what kind of weather patterns, what kind of life could even exist in such a place.
Yeah, it sounds like a world of stark contrasts. Anything even wilder out there?
Absolutely. How about K2-141b?
Yeah.
Now, this is truly bizarre.
Okay, I'm ready.
Imagine a planet where one side is covered in a magma ocean.
A magma ocean.
Molten rock reaching temperatures over 3,000 degrees Celsius.
Oh, my goodness.
And the other side is locked in freezing darkness.
Hold on, a magma ocean.
Yeah.
That's insane.
And it gets even weirder.
Okay.
The intense heat on the day side causes rocks to vaporize, and those vapors are carried by supersonic winds to the night side, where they cool, condense, and rain down as molten metal.
Metallic rain.
Metallic rain.
It sounds like something straight out of science fiction.
It does, but it highlights this incredible diversity of planets out there. And then there's GJ-1214b, a planet that takes water world to a whole new level.
Okay, isn't a water world just, well, a lot of water?
Yeah. But GJ-1214b is thought to be completely covered in water with an ocean hundreds of kilometers deep.
Wow.
No continents, no islands, just endless water beneath a steamy, hazy sky. We're not even sure where the ocean ends and the atmosphere begins.
So not exactly a place for beachcombing.
Probably not.
These extreme worlds, are they rare, or is this what's normal out there?
That's a question we're still trying to answer, you know? The more exoplanets we find, the more we realize how limited our Earth-centric view is.
Right.
Maybe these seemingly bizarre worlds are more common than we think.
It's mind-boggling to think about, okay, we've explored scorching hot planets, potential water worlds. Now, what about something a bit darker?
Ooh.
Let's talk black holes.
All right.
The ultimate cosmic enigmas.
Regions of space-time where gravity is so strong that nothing, not even light, can escape.
And we have one right in our own backyard, so to speak.
Right.
You mean V616 Monocerotis, the closest black hole to Earth?
That's the one. A stellar mass black hole about 3,300 light-years away. It's part of a binary system, slowly pulling matter from its companion star.
Oh, wow.
This matter forms a swirling disk of superheated gas glowing brightly as it spirals into the black hole.
It sounds almost beautiful in a terrifying kind of way.
It is. It's a delicate dance of destruction.
Right.
But it pales in comparison to the monster lurking at the heart of our galaxy, Sagittarius, the supermassive black hole that holds the entire Milky Way in its gravitational grip.
I remember seeing that image of Sagittarius A. The blurry orange donut. It's hard to believe something so massive can be so compact.
It is mind-boggling. Sagittarius A packs a mass of over 4 million suns into a space smaller than our solar system.
Wow.
We're talking about an object that warps space and time itself.
So what's it like near a supermassive black hole? Is it just darkness, or is there something more going on?
It's a region of intense activity, a chaotic mix of stars, gas, and dust swirling around the black hole at incredible speeds. Some stars, like S62, orbit so close they reach speeds of 6.7% the speed of light.
I can't even comprehend that kind of speed.
Yeah, it's hard to wrap your head around.
Yeah.
And beyond these daredevil stars, there's this central molecular zone, a region further out where new stars are being born. It's a reminder that even in the most extreme environments, creation and destruction go hand in hand.
So the Galactic Center is this wild mix of intense gravity, superfast stars, and stellar nurseries. What's next on our cosmic road trip?
Well, we've explored the heart of the Milky Way now. Let's zoom out a bit and take a look at the grand structure of our galaxy. We live in the galactic disk, right?
Right, the flat rotating disk of stars, gas, and dust that makes up the most visible part of the Milky Way. It's like a giant cosmic pizza.
I like that. And our solar system sits on one of the spiral arms, the Orion arm.
Okay.
It's one of several major arms like the Perseus arm and the Scutum Centaurus arm, which are regions of intense star formation.
I've always been curious about those dark patches we see in the Milky Way.
Mm.
What are those?
Oh, those are dust lanes, regions where dense clouds of interstellar dust block the light from stars behind them. One prominent example is the Great Rift, a dark band that stretches across a significant portion of the Milky Way.
So those dust lanes are actually hiding even more stars.
Exactly. And these clouds aren't just blocking light, they're also the raw material for future star formation.
Oh.
They're rich in hydrogen and other molecules, the building blocks of stars and planets.
It's amazing to think that even in those dark patches, new stars and planets are being born. What lies beyond the disk?
Beyond the disk is the Galactic Halo, a vast spherical region that surrounds the disk. It's much less dense, but it's home to some fascinating objects like ancient globular clusters.
Globular clusters.
They're tightly packed spherical collections of hundreds of thousands, even millions of stars, some of the oldest stars in the Milky Way. Imagine these ancient swarms of stars orbiting the galactic center like bees around a hive.
And there are also these stellar streams, right? I remember reading about the Sagittarius stream.
Oh yeah, the Sagittarius stream is a long ribbon-like structure of stars that wraps around the Milky Way. It's believed to be the remnants of a dwarf galaxy that was captured and torn apart by the Milky Way's gravity.
So the Milky Way is kind of a galactic cannibal.
In a way, yes. Large galaxies often grow by absorbing smaller ones. It's a reminder that even on a galactic scale, there's a constant struggle for survival and dominance.
And then there's the dark halo, this mysterious region that we can't see directly.
Right, the dark halo. It's thought to be a massive halo of dark matter that extends far beyond the visible galaxy. We can't see dark matter directly, but we know it's there because of its gravitational effects on the visible matter.
So even though we can't see it, it's holding the entire galaxy together.
That's the current understanding. Dark matter makes up the vast majority of the Milky Way's mass, and it plays a crucial role in the galaxy's structure and evolution.
Wow. It's incredible to think that we're surrounded by this invisible, massive halo.
Mhm.
What stands out to you from this whirlwind tour of the Milky Way?
What strikes me is the sheer scale and diversity. We tend to think of planets and stars as being somewhat uniform, but the reality is far more bizarre and wonderful. From magma oceans to super-Earths, from black holes to stellar streams, the Milky Way is a cosmic tapestry woven with threads of wonder and destruction.
It's certainly been an eye-opening journey so far.
Yeah.
But there's so much more to explore, so much more to learn about our galactic home. Stay tuned for part 2 of our deep dive into the Milky Way, where we'll delve deeper into some of the most intriguing objects and phenomena we've encountered on our journey.
Sounds good.
I can't wait.
Me neither. Welcome back to our cosmic voyage through the Milky Way.
Last time we journeyed from our stellar neighbors all the way to the Galactic Halo,
we did.
encountering black holes and star streams along the way.
It's amazing, isn't it?
It really gave us a sense of the Milky Way's vastness and diversity.
Absolutely.
Today, I'm excited to dive deeper into one of the most captivating areas of modern astronomy, exoplanets.
Ooh, yes.
These worlds orbiting other stars have captured our imaginations for decades.
For sure.
And what we've learned so far is that the universe is far stranger and more wonderful than we ever imagined.
It really is.
We touched on some pretty mind-blowing examples last time,
Yeah.
like K2141b,
Oh, yeah.
with its magma ocean and metallic rain.
K2141b is a perfect example of how extreme exoplanets can get. It's tidally locked to its star.
Right.
Meaning one side always faces that scorching heat,
Yeah.
while the other is shrouded in eternal darkness.
What are the implications of a planet being tidally locked like that? Does it affect its habitability?
It definitely creates some extreme conditions, you know? The temperature difference between the two sides would be enormous, leading to some truly bizarre weather patterns. While we wouldn't expect to find life as we know it on K2141b,
I see.
it does make us rethink our definition of what a habitable planet could be.
So even in these seemingly hostile environments, there's still so much to learn.
Absolutely. Each exoplanet we discover, no matter how strange it seems, challenges our preconceived notions
Yeah.
and pushes the boundaries of our understanding.
We also talked about GJ1214b, a planet that's basically a giant water balloon.
Ah, yes. GJ1214b, a fascinating example of an ocean world.
Totally.
We believe it's entirely covered in water,
Wow.
with an ocean hundreds of kilometers deep. And its atmosphere is so thick and steamy
Yeah.
that it's difficult to tell where the water ends and the sky begins.
It makes you wonder what kind of life could exist in such a watery world.
It's a question that sparks the imagination, for sure. Could there be creatures adapted to crushing pressures and eternal darkness,
Right.
swimming in the depths of that alien ocean?
It's a reminder that life might find a way even in the most unexpected places.
Absolutely.
Okay, so we've explored some of the more extreme ends of the spectrum.
We have.
What about planets that are more Earth-like? Have we found any yet?
The search for Earth 2.0 is one of the most exciting frontiers in astronomy.
I bet.
We've found a number of intriguing candidates.
Oh, really?
Planets that are similar in size and mass to Earth and orbit within the habitable zone of their stars.
You mentioned habitable zones before. Can you explain exactly what that means?
Sure. The habitable zone, also known as the Goldilocks zone, is the region around a star
Okay.
where temperatures are just right for liquid water to exist on a planet's surface. Not too hot, not too cold, just right for the potential for life as we know it.
So if a planet is in the habitable zone, does that mean it's definitely habitable?
Not necessarily. While being in the habitable zone is a good starting point,
Okay.
there are many other factors that can influence a planet's habitability,
Like what?
like its atmosphere, its magnetic field, and the activity of its star.
So it's not as simple as just finding a planet at the right distance from its star.
No, it's not. There's a complex interplay of factors that determine whether a planet can support life. But finding planets in the habitable zone is a crucial step
Right.
in our search for other worlds that might harbor life.
What are some of the most promising Earth-like candidates we've found so far?
One intriguing planet is Wolf 1061c, a super-Earth orbiting a red dwarf star just 14 light-years away. It's one of the closest potentially habitable exoplanets we know of.
Being so close, does that mean we could actually study it in detail?
With the next generation of telescopes, we hope to be able to study the atmospheres of planets like Wolf 1061c,
Oh, wow.
looking for signs of gases that might indicate the presence of life.
That's incredible.
Oh.
What other Earth-like planets are on our radar?
Another interesting candidate is Gliese 667cc, a super-Earth orbiting a red dwarf star about 22 light-years away. It's also located within the habitable zone
Okay.
and could potentially have liquid water on its surface.
It seems like we're finding more and more of these potentially habitable planets every year.
We are. With advancements in technology, our ability to detect and study exoplanets is rapidly improving. It's an incredibly exciting time to be involved in this field.
So we've talked about planets with magma oceans, water worlds, and potentially habitable super-Earths.
Yeah,
It seems like the possibilities are truly endless.
they are. And as we continue to explore the Milky Way, we're bound to discover even more bizarre and wonderful worlds that challenge our understanding of what's possible.
It makes you realize just how much we still don't know about the universe
It really does.
and how much there is left to explore. We've covered a lot of ground in this episode,
We have.
from scorching hot planets to potentially habitable worlds.
Yeah.
But our journey through the Milky Way isn't over yet.
No, it's not.
Welcome back to Cosmos in a Pod.
We're back.
It's time for the grand finale of our journey across the Milky Way.
The grand finale.
We've explored alien planets, navigated star clusters, and now we're heading straight for the most extreme environment in our galaxy.
That's right, the Galactic Center, a realm ruled by a supermassive black hole.
Before we get too close to that cosmic monster, let's talk about what makes Sagittarius A so special.
Okay, Sagittarius A, or SGRA for short, is a supermassive black hole that's lurking at the very heart of the Milky Way. Imagine an object with a mass millions of times greater than our sun,
Millions of times.
squeezed into a space smaller than our solar system.
Millions of times the mass of our sun. That's mind-boggling.
Yeah.
How can something so massive be so incredibly compact?
Well, it's one of the most bizarre consequences of Einstein's theory of general relativity. When a massive star collapses at the end of its life, its core can implode,
Oh, wow.
crushing itself into an infinitesimally small point. And the gravitational pull becomes so intense that nothing, not even light, can escape its grasp.
So how do we even know SGRA is there if we can't see it directly?
For decades, astronomers suspected its presence based on the strange movements of stars in the galactic center. These stars were whipping around an invisible point at incredible speeds as if being tugged by an unseen force.
And then a few years ago, we got that incredible image of SGRA's shadow, confirming what astronomers had long suspected.
Exactly.
Yeah.
The Event Horizon Telescope, a network of radio telescopes around the world, captured that first ever image of a black hole's shadow.
It was amazing.
It was a blurry orange donut shape, but it represented a monumental achievement in our understanding of these enigmatic objects.
So what's it like near a supermassive black hole? Is it just darkness and silence, or is there more to it?
Oh, it's far from a quiet void. The region around SGRA is a maelstrom of activity.
Really?
Stars, gas, and dust are swirling around the black hole at breakneck speeds. Some stars, like S62, orbit so close that they reach a significant fraction of the speed of light.
I can't even imagine what it would be like to witness that firsthand.
I know, it's hard to comprehend. The sheer power and energy must be overwhelming.
So it's not just about destruction. There's also a creative force at play in the Galactic Center.
That's right. Black holes, despite their reputation as cosmic vacuum cleaners, might actually play a crucial role in the evolution of galaxies.
How so?
They can trigger star formation and regulate the growth of galactic structures.
It's fascinating to think about the interconnectedness of all these cosmic phenomena. From the birth of stars in stellar nurseries to the death throes of massive stars collapsing into black holes.
Yeah.
It's a constant dance of energy and matter.
It really is a beautiful and awe-inspiring dance.
And our journey through the Milky Way has given us a glimpse into this grand cosmic dance, from the familiar stars in our night sky to the most extreme objects in the universe.
Absolutely.
It's been an incredible journey exploring the vastness and diversity of our galactic home. We've encountered planets that defy imagination, witnessed the birth and death of stars, and ventured into the heart of a supermassive black hole.
What a journey it's been.
And as we conclude our cosmic adventure, we hope you've gained a newfound appreciation for the wonders and mysteries that lie hidden within our own galaxy.
There's so much out there to explore and discover.
If you've enjoyed our deep dive into the Milky Way, be sure to subscribe to Cosmos in a Pod and follow us on YouTube for more cosmic explorations.
We'd love to have you join us.
Until next time, keep looking up and keep wondering.
The universe is full of secrets waiting to be discovered.